All right, so I'm live with 52 weeks of AWS, and I'm going to cover developing with AWS S3. I'm going to get right into it, still preparing for the Solutions Architect certification exam, and I'm going to dive right into this material here, make this a little bit bigger. Perfect. Looking good. Okay, so let's dive into S3 here. So the idea here with S3 is that it really is like the center place where you would build out data availability, scalability. It's essentially got infinite disk I/O, infinite storage, and so it is something that most people want to build on top of it. And a lot of managed services on AWS are actually built on top of it. So some of the use cases include, content storage and distribution. So I actually personally do this. I deploy multiple static websites to S3, and that gives them global scale, right? So that's a huge reason to do S3. Backup is another great reason. Archiving, it actually can do snapshotting. It can do synchronization to backup systems like Glacier. Also, data lakes and big data analytics, also disaster recovery and static website hosting, as I just mentioned. Now, the data lake and big data analytics, this is actually kind of an interesting one because the managed services like Athena and also Glue and also SageMaker, they all fit on top of this. And if you look at some of the components of S3 here, some of the components include really the URL. And so you can see here that there's a region-specific endpoint. Each bucket is regional, and the names have to be globally unique names for that particular region. And then the bucket is the bucket name, and then the object key. So that could be like, file.mp4 or whatever it is you're going to put in there. Now let's talk about creating Amazon S3 buckets. There, as I mentioned before, the names have to be globally unique. And so additional rules would be, they have to be between 3 to 63 characters. You want to only use lowercase letters, numbers, and hyphens. This trips me up all the time. I always forget to do it. You don't use uppercase characters or underscores. You don't use a period when you're using virtual hosted style buckets with SSL. So a few things to be aware of is that when you create a bucket, that there are different regions that you can put the bucket into, right? You can put it into the East Coast, the West Coast, in Europe. You can put in Asia, and there's going to be different reasons to put these in different buckets. So, for example, the regulations, right? We may enter a period where there's actually a lot of oversight around data, and in the European Union especially, you may have to actually be very careful to only put things inside of the European Union and not send that data back over to the United States. Latency is another one, right? If you're building things and you have too much latency, then you're not going to be effective in terms of what you're building. So when you're accessing the bucket name is not a part of the domain. And also with virtual hosted style URLs, the bucket name is part of the domain in the URL. And so this would be useful for hosting, let's say, a static website, which you do have to actually enable that. But it does, the good news is that actually it does work very well with Route 53, and it's a great service actually. So creating a folder structure and bucket, a few different things to be aware of is a prefix will imply a folder structure in an S3 bucket. You would specify, for example, the year, the directory structure, and then some folder underneath, and then that would actually return back what's going on. So it's really just like a nested hierarchy, a lot like a file system, is a bucket. So let's talk about working with objects in Amazon S3 next here. A few things to be aware of is that unique identifiers for a bucket object. The key encoding would be UTF-8. The maximum key length is 1,024 bytes. The key names would be alphanumeric characters, special characters, and path prefixes and delimiters. So some of the examples could be, for example, AWS -ACD /v1.0 /labs.html, right? So you can get a little more creative when you're creating the keys themselves. The metadata is pretty interesting in that this is a set of key value pairs that has additional information about the object. So the system itself in Amazon will do things like um, control S3. Um, it'll have creation date, object size, object version, and you can also modify storage class configuration. So do you want it to be frequently used or infrequently used? Server-side encryption, and then also user defined. This would be other metadata that you would assign to it, and you would use the X-AMZ-meta key. And so a good example would be, you're assigning it to a particular project. For example, if you wanted to do, project tracking and do some kind of financial monitoring, that could be a good use case for that. So the put object, this is when you upload the entire object to a bucket, and this can be, basically a single upload for an object up to 5 gigs, and it could be a put operation. And the size in terms of that for a single upload again would be under 5 gigs, and for a multi-part upload, the size would be under 5 terabytes. Right? Recommended would for multi-part would be like to break it into 100 megabyte chunks so that you could get the most throughput in a parallel upload. The multi-part uploads, though, one of the really cool things that you can do with it is that you can resume when you actually left off. So a get object is an operation to retrieve the object from S3, and so you would actually get it in one request, and you can also get a range of bytes as well, which is actually pretty useful if it's a huge object. So to select an object, one of the things you can do is you can select object content operation to filter the contents of an object based on a SQL query, which is really amazing, actually. And one of the ways that you can do that is by just filtering out, a query. And because of that, you don't have to actually scan the entire object, right? You can actually get performance increases up to, let's say, 400% and reduce the query costs by as much as 80%, right? So this is definitely a pretty cool topic. Now, versioning is another one that is easy to forget to do, but in terms of human error, this is a really important thing to keep into your thought process, is that if you're able to keep multiple variants, you don't have to worry about someone accidentally programmatically destroying something because you had multiple versions. And you can also use it to recover from, a user that did something, bad, which happens all the time. And if you have version enabled buckets, each object has a version ID associated with it. And you can even suspend it as well if you don't want to use it. And you can also do object locking for the version bucket. So this, depending on what kind of environment you're in, it's a little bit more expensive, but it could be a lifesaver, because if the data is, cancer research or something like that, where if it was destroyed, it would be, a huge problem, then this is a really a great, way to get around that problem. Now, delete object is another thing you can do. So the versioning is disabled in that scenario, and so with S3 bucket, you can actually delete a MP3 file, for example, and you could delete either a single object or multiple objects. And it is not a versioning enabled, so you can permanently delete an object by specifying the key of the object you want to delete. And now if there's versioning enabled, one of the things you have to do is you would have to invoke a request for each of the keys as well as each of the versions, which I think is definitely what you want. You don't want a cascading delete without specifically saying which versions, or else it kind of defeats the entire purpose of doing a versioned file system. So let's talk next here about protecting data and managing access. I mean, this is really an important topic, I think, for many people. And one of the ways that you can secure your system is to do securing the data in transit. So SSL, TLS encrypted endpoints, client-side encryption. You can also secure data at rest. So you can do client-side encryption, server-side encryption. You can do Amazon S3 managed keys, AWS KMS managed keys. All these are great ways to handle data encryption. So the concept in general with data in AWS is you want to actually have it secured in the transit. So you can think about this in the Old West, right? They had the person with the shotgun on top of the stagecoach. right? That's securing it in transit. And then the rest part, the same thing with the Stagecoach, they would have the safe inside of the Stagecoach, and it would be locked up inside of the safe. So you can think of the Stagecoach as a great concept for why you need to secure it in transit and secure it in rest. Really, you need both. Okay, user policies and resource based policies. There are identity based policies and there's resource based policies. So an identity would be linking things together with a user. And so the user has privileges to do certain things. The resource based policies would be attaching them to a specific resource. So, like an access control list, for example. So, they're both very important ways of controlling access to different parts of AWS. Now, an access control list or ACL is pretty interesting because it allows you to manage things at the bucket or object level, and you can grant read and write permissions to other AWS accounts. So this gives you a little bit more fine-grained control, right? So you could actually have HR data, for example, inside of S3, and you could actually manage it that way. And the ideal recommended use case for this is to grant write permissions to S3 log delivery group, and then actually also keep track of the auditing for what's happening. Now, bucket policies are fairly straightforward. They're JSON-based language and or configuration, and you put it inside and you say the version, the statement, you have an effect, and you have the action, and then you assign it to a particular resource. So you would assign it to, let's say, a particular bucket. And in terms of pre-signed URLs, this is another powerful way to do things. We can provide access via put or get objects without opening permissions. You can use permissions of the user. You can provide security credentials, a bucket name, an object key, HTTP method, and an expiration date and time. And these are only valid until maybe a week or so. And so this is a great example of the way it would work is you have inside of your availability zone, you would generate a URL. There would be a request that's pre-signed. You would return back the pre-signed URL, and then someone could actually explicitly manage, access to that particular resource, and you could have an expiration time associated with it. So these are a great resource for actually, giving people access to S3, and it's used very commonly in many, consumer applications as well as B2B applications. There's also cross-origin resource sharing or CORS. And so in that particular scenario, you would have the ability to have a web client that's maybe a single page app. It's in JavaScript. It can actually make API calls to other resources, and you can actually enable that inside of the S3 environment. So, some of the things to be aware of here are that, I would recommend if you want to play around more with S3 is, make a bucket, upload some things into a bucket, change the policy, try out website hosting. I would also recommend another thing to play around with here would be to play around with using the Cloud Shell environment with AWS and also Cloud9 to interact with S3. I think those are two of the really good ones for a developer to play around with. And a third one would be to use the AWS Lambda trigger that can communicate with S3. So if you put files inside of S3, you can look at the actual put request, and you can actually capture that and then do some kind of operation. You could make a little simple one that just prints out the name of the file or something like that. So those are the three things I would definitely play around with from a developer perspective so that what's happening with S3. So next week here, we're going to cover DynamoDB, which is one of my favorite databases because it's simple. It's basically like a dictionary. Thank you for everybody that showed up, and see you next week. We'll cover DynamoDB.